Today's topic is motion in one dimension. Okay. Motion in one dimension. What are the basics of this motion in one dimension? What are the basics of this? Okay. Already we have discussed some of the basics like average speed, average velocity, distance, displacement. These are some of the basics we have already covered. Now all reals will start from today onwards. Means what are the main things? What are the main concepts? Okay. So what the next we are going to do, we will plan for that. Okay. So just see here now. The first equation of motion, that is v is equal to u plus at. Or the second equation of motion is ut plus half at square, and v square minus u square is equal to 2as. Okay. These are called as the fundamental equations on which the whole kinematics is going to depend upon. Okay. So complete kinematics depends upon these equations. The complete kinematics depends upon these equations. You need not worry of writing you need not worry about writing of notes, because the video is getting shooted and this PDF will be sent to your WhatsApp numbers. We will add your WhatsApp number in the group and we'll send the PDF also. Your work is be free, be cool, observe the class, listen carefully and try to grasp the subject. Okay. So this is the only work. No burden of writing the notes, no burden of that I will miss this class, I will miss this topic, what happens? No, you can revise 10 times because this video will be sent to your WhatsApp numbers. The pure basics I am discussing today. Now here, to understand these equations of motion, first of all you should understand what is the meaning of VT graph. What is the meaning of VT graph? Okay, so what is this VT graph actually? This is called as velocity time graph. Okay, this is purely NCERT 11th class basics. Purely NCERT 11th class basics I am discussing, which will help for NEET and JEE Main students. Today's class is pure basics and you will enjoy the class inshallah. Okay, so what is this going to happen now? For example, if I draw the graph like this, okay, if I draw the graph like this is y-axis and this is going to be your x-axis. Okay, this is your x-axis and this is your y-axis. And y-axis is having velocity and x-axis is having time here. Okay, so time which is represented with letter T, velocity which is represented with letter V. How can you convert the live present situation in terms of graphs? That you have to learn now. Okay, so let us imagine there is one car here. Okay, and this car is moving forward. It is having initial velocity 0, it is having final velocity, let us imagine it's going to be how much? 4 meters per second, and it is having time t. It has taken time t to travel from here to here. What do you understand from this? Slow increase in velocity is called as acceleration. If any body has increase in velocity with respect to time, it is called as an acceleration. So how will you represent this situation in terms of graphs? Okay, so let me draw one graph here to understand that situation here. Okay, so for that you can just see as the body starts from 0, this is the case of time and this is the case of velocity. That's why it is called as velocity time graph. At time t is equal to 0, time starts from here. No? Time starts here. Okay, time t is equal to time t is equal to 0. Okay, after time t is equal to 2 seconds, the body is here. How do you represent this situation in terms of graph? Very simple. When time is 0, velocity is 0. Velocity of a car is 0. That means your graph starts from here. Your graph starts from here. Okay. Up to where it is going to start? This is 1, this is 2, this is 3, and this is 4. Okay. So velocity starts from 0 and increases up to 4. And time taken is 2 seconds, means this is 1 second and this is 2 seconds. So if I draw here one line like this and one line like this, Let us imagine this line to be 1 second and this line to be 2 seconds. Now I have represented this situation in terms of graph now. See, gradually velocity is increasing. Gradually velocity is increasing. So it starts from 0, slowly velocity increases. So what is this point? This point represents the maximum velocity. At this place, velocity is 4 meters per second and time is going to be 2 seconds. So I have represented it in the form of a graph now. Hope you are understanding. Now I will represent the same in a different situation now. Okay, what I am going to do now? I will draw the same graph now, where this is going to be y-axis and this is going to be x-axis, and also now I am representing the graph like this. Will you tell me what this graph is different from the previous graph? In what way this graph is different from the previous graph? I'll discuss about that. See, this is the y-axis which represents velocity and this is representing time here. So it's not 0 now, it is starting from certain initial velocity. It is starting from certain initial velocity u. And this is going to be the final velocity v. Now, here. So if I draw the graph, if I draw the lines like this. Just here now. I'll complete this graph now, here, like this. Okay, so first thing what I am going to explain from this graph is, try to imagine the situation. Graph means lines. By seeing the lines, you have to imagine the situation, which is a great challenge before you. So what is the situation now? Let us take one small example where a body starts from certain initial velocity 1 meter per second and it has gone to final velocity 4 meter, or this is going to be 5 meters per second, and it has taken a time of 2 seconds to reach from here to here. That means already body has certain initial velocity. It is not starting from 0. Already it is having certain initial velocity and slowly its velocity is increasing. Okay, so you have to show that in the graph it is having certain initial velocity, and that is represented with this, that is 1 meter per second, and final velocity is here, which can be represented with final velocity v, which is taken as 5 meter per second. From here to here time taken is how much? 2 seconds, means it is 1 second and this is going to be 2 seconds. Okay, so this is the graph. Now the challenge before is, how can you find out an acceleration from the graph? In general, you all know acceleration is nothing but, okay, acceleration is nothing but increase in velocity. Increase in velocity by time taken. This is a general formula. As the time passes, if the train starts from a station, gradually its speed will increase, its velocity will increase, let us imagine, as the time passes. We say that train has an acceleration. We say train has an acceleration now. So that acceleration, in general, we write increase in velocity means how much? It is moving from u to v. That means increase means final minus initial by time. This is going to be the final velocity. This is going to be the final velocity, and this is going to be the initial velocity, isn't it? Now what is going to happen? Change in velocity with respect to time or increase in velocity with respect to time is called as an acceleration. And for example, the train is approaching the station, you will feel that gradually its speed is decreasing and it stops near the station. It's not having any disc brake like our bike, that suddenly if you stop with the first disc brake, the back part will raise. If the train's back part will raise, what happens? If you suddenly apply the brakes, what happens? What about the backward bogies? They will raise or they will collide with each other and come out of the track, isn't it? There is no chance that just like your race bikes, suddenly you can raise the train and it is standing like this, like a snake. Just a bike. If you raise, what happens? The front tire will rise. Not happening with train like that, isn't it? Gradually it has to increase its speed. Slowly it has to decrease its speed. The locomotive pilot has to decide that after 5 kilometers there is a station, I have to apply the brakes from now onwards. Because train has to be controlled from 5 kilometers before. By seeing the signal, it has to apply the brakes slowly. So train, a larger body, heavier body. which is having greater momentum. People having greater momentum cannot be stopped immediately. A 120 kg boy is running. And he is coming so fastly, and you want to stop him. Hey, stop! Hey, stop! No, he will not stop because his momentum is larger. He will carry you also along with that, with him, because he cannot control his speed. Heavy, smaller bodies having lesser momentum. If you ask them to stop, they'll stop there only. But heavier bodies having more inertia of motion. Okay, that's the next topic here. So what I'm going to say is, now you got an acceleration. Means final velocity minus initial velocity by time. So we write v minus u is equal to at, v is equal to u plus at. This is called as the first equation of motion. Okay, this is going to be the first equation of motion. Can you derive this equation of motion by seeing this graph? Yes, you can do that. Okay, so what is an acceleration here in terms of graphs? Or what is acceleration in terms of graphs? It's a very simple thing that if you find the slope of the graph, okay, acceleration is nothing but slope of a graph. Slope of a graph. And what is the meaning of slope here? Slope is nothing but tan theta. And where is theta here? It is going to be theta here. It's going to be tan theta. And you all know tan theta is nothing but opposite side by hypotenuse. Opposite side by hypotenuse. That is called as tan theta here. Then what is going to be your opposite side? Yes. I'm really sorry. Opposite side by adjacent side. Okay. So tan theta is nothing but opposite side by adjacent side. So it's going to be this one. So this is final velocity from here to here. And if you observe, if you compare this on the other side, this is going to be initial velocity. These both are initial velocities, and this is going to be the final velocity. That is v here, both are same. U here is both are same here. Now let us name this one. This is A, B, and this is C, D, and this is going to be E, for example. Okay. So what is going to be the slope? Tan theta is nothing but opposite side. So if you want to measure the opposite side, this is V and this is U, then what is going to be this point? Okay. Now we want this part, because this is finally V. So from here to here it is V, and this is going to be U. From here to here it is going to be U. Then I want the middle part, then we will write final minus initial, that is going to be V minus U. Okay, so here tan theta is nothing but opposite side. Opposite side is nothing but AB, and adjacent side is nothing but AC. Opposite is AB, adjacent side is AC. That is going to be the slope. Okay, in mathematics, slope means nothing but tan theta. Okay, tan theta. Tan theta is nothing but opposite side by adjacent side here, isn't it? Okay, AB by AC. So what is this tan theta going to give you? Acceleration. So acceleration is nothing but here. Now just see. Opposite side is nothing but V minus U, and adjacent side is nothing but T here. Okay. So this implies that V minus U is equal to AT. So V is equal to U plus AT. So I have explained the same concept by using even graphs also. Hope you are understanding. The same concept I have explained by using graph also. This is your basic of kinematics. Okay. So once you understand this one, then what about the next equation of motion? We'll discuss about that. What is the next equation of motion? So that is going to be S is equal to ut plus half at square. Okay. So how do you understand this one? For that you have to imagine one situation. And what is going to be that situation? Let us consider, see, every time you need not draw the car because it takes a lot of time, and a person who knows drawing should be a good drawer. So as I am not a branded drawer, I cannot draw the diagrams so beautifully. Let me adjust with one small ball or take at one tire of a car. That's it. Okay. So which is having initial velocity. Already it has some initial velocity 1 meter per second. It's having final velocity 5 meter per second. It's having a time which is, let it be imagining 2 seconds as the previous situation here. Now, what is the displacement traveled by a body? This is going to be the displacement traveled by a body. A football is having some already velocity, 1 meter per second, and you want to pass to your friend, or you want to throw this ball inside the goal, then already moving ball, if you kick faster, if you kick certain force, its speed increases from 1 meter per second and strikes the goal with a speed of 5 meters per second. And if your shot is powerful, the ball will carry even goalkeeper also inside. तू मैं एक साथ मिलके घुसी अंदर बोल. Okay, so it happens like this. So this is going to be the total situation. Now, how are you going to derive? By using just the situation. Deriving by using graph is the different case. Now let me imagine the situation and derive the equation. How will you do this now? See, the simple formula is as velocity is equal to displacement by time, displacement is nothing but velocity into time. As velocity is not uniform, what is the meaning of uniform velocity? You're wearing school uniform and having certain velocity? No. Uniform means constant. Constant velocity is called as uniform velocity. Okay, so it's not having any constant velocity. Initial velocity is different, final velocity is different. So we need to consider what is average. Average is nothing but initial plus final by time. Okay, sorry, initial plus final by 2. Average is nothing but sum of the velocities by number of velocities is called as an average, isn't it? Sum of the velocities by number of velocities is called as an average. So that is V average is nothing but U plus V by 2. Okay, so here also as velocity, if velocity is uniform, the simple formula is displacement is nothing but constant velocity into time. But velocity is not constant, so you have to consider average. So you just write average velocity into time. S is equal to average means U plus V by, what is that? Is 2 into T. Hope you are understanding now. Okay, so let us take this situation now and derive the equation. So once you got the displacement, you can find out the displacement very easily now. That is going to be S is equal to U is 1 and finally V is 5. This is going to be 2. It has taken 2 seconds, so it's going to be 6 by 2 into 2. 2 gets cancelled. So your body has traveled, your car has traveled, your bike has traveled, your ball, your football, volleyball, handball, whatever it may be, except head ball. Okay, so all are moving with the displacement. You got the displacement now? Yes. Okay. Now, this is a basic formula, I can say. What is this? This is going to be our basic formula. But I need to derive what is ut plus half at square. What shall I do now? What shall I do now here? Okay. So, as S is equal to U plus V by 2 into T and V is equal to U plus AT, which is already known to us. This is 1 and this is 2. Okay. This is 1 and that is 2. Then what will you do? Substituting 2 in 1. Substituting 2 in 1. Okay. So what are you going to get now? S is equal to U plus V means what will you write? U plus AT divided by 2. Okay. Into T. So S is equal to U plus U. Is it okay? Huh? Sorry. So what I have done? So S is equal to U plus V. V means what will you write? U plus AT, isn't it? Divided by 2. Just in the place of V, I have placed U plus AT. Understood? It was V here because U plus V by 2. And you know the formula, we have already derived this by using situation as well as graph. So I got this formula, I have substituting this formula here. That's it. So what I am going to get now? So the next step is you'll write 2U plus AT divided by 2 into T. So partially you have to divide. Before that you make this T also go inside. It's going to be 2UT plus AT square divided by 2. So what is going to happen if you partially divide? One thing is 2UT by 2 plus AT square by 2. Okay, so what's going to happen now? 2 gets cancelled. Therefore, S is equal to UT plus that half if you take outside It is going to be half at square. So got the displacement? Understood all of you? Okay, so you got the displacement now. The simple thing is you have taken two steps. Let me repeat. You have used only two steps. What is that you have done? General definition, basic knowledge of your 8th, 9th and 10th is you all know velocity is nothing but displacement into time. And displacement is nothing but velocity into time. Velocity is constant means you keep just v into t. If velocity is not constant, slowly it is increasing, then you have to consider two situations where initial velocity is u, final velocity is v, and take the average which is v, u plus v by 2. And displacement, if it is not constant, velocity is not constant, you take average velocity into time, where in the place of average velocity you will keep like that and time you multiply. So this is one formula to find out the displacement. You got the displacement by using this formula also. But what can you do now? Next step, because our final destination is this equation, which is very important. Universally accepted equation, that is S is equal to ut plus half at t square. I want this equation. So what I am going to do? The previous equation is v is equal to u plus at, which we have already derived in the previous case. And this situation is already known to us here. So take this v, keep here. V is nothing but u plus at. U plus at. U plus u is 2u and at by 2. So send this 2 inside. T also inside is going to be u plus u is 2u, 2ut plus at into t square. That's it. So here you all know, for small children I am telling you, I know grown-up children already know that x plus y by 2 is written as x by 2 plus y by 2. Grown-up children already know, because there are some kids here who doesn't know what is the meaning of partial division. So x plus y by 2 can be written as x by 2 and y by 2. Hope you are understanding. So the same thing I have done. This is x and this is y by 2, is x by 2 separately, y by 2 separately I have taken. Cancel out this 2 and got the final destination. But can we prove this? Can we prove this by using graphs? Yes, why not? We can prove this by using graphs also. Okay, so what is that? This is, and this is. The same graph which I have used previously. Okay. Just see now. The same graph which I have used previously, and this is going to be initial velocity here, and from here to here it is going to be final velocity, and this part is representing the time because this is time graph and this is velocity along the y-axis, isn't it? Okay. Now, today we are going to find out what is the displacement. What is the displacement in the case of velocity time graph? Okay. Now, what we need to do to find out the displacement? Let's see here now. Okay, so in general, in common sense, if velocity is nothing but displacement by time, displacement is nothing but velocity into time. Okay. If you know this velocity is nothing but displacement by time, you all know that displacement is nothing but velocity into time. In terms of graph, if I want to represent, okay, for example, this is a graph like this, which is having time, which is having velocity. Okay, now this is a straight line graph, velocity time graph, where this graph represents it is having a constant velocity. It's moving with a constant velocity. From this graph, you want to find out the displacement. Then what will you do? You all know displacement is nothing but velocity into time. So velocity is going to be the breadth and time is going to be the length. That means if you want to find out area, you will write length into breadth, isn't it? As displacement is also product of velocity into time and area is also length into breadth, from this situation you understand one thing, that in a velocity time graph, if you want to find out an acceleration, you have to find out the slope. If you want to find out the displacement, you have to find out the area of the graph, isn't it? Is it clear what I am saying? Let me repeat once again. If you want to find out if you want to find out an acceleration in this graph, what you are going to do? You are going to find out angle theta. Acceleration means angle. Slope of velocity time graph gives you acceleration. Area of velocity time graph gives you displacement. Understood? Why is it so? Because acceleration is nothing but change in velocity by time, where change in velocity is in the opposite direction and time is in the adjacent side. And you all know slope is going to be what? Acceleration. What is this slope? Slope is nothing but acceleration. And this slope acceleration, if you want to find out, you have to apply tan theta, which is going to give you slope. So slope means opposite side by adjacent side, which is change in velocity, where delta v is nothing but v minus u. Already I said this is the final velocity, this is the initial velocity. Try to understand the situation. If a body has initial velocity, already I told you 1 meter per second, and its final velocity is how much? Capital V is 5 meters per second, and time taken is 2 seconds. So starting lo 1 meter per second undindi, slowగా స్పీడ్ పెరిగి 5 meters అయింది, దానికి 2 seconds పట్టింది. ఈ సిచ్యువేషన్ ని గ్రాఫ్ లో రిప్రజెంట్ చేస్తున్నాం. ఇనీషియల్ గా జీరో లేదు అక్కడ, ఆల్రెడీ సడన్ వెలాసిటీ ఉండింది కాబట్టి నేను గ్రాఫ్ ఇక్కడ నుంచి మొదలు పెట్టాను. అంటే ఏంటి? ఈ u వచ్చేసి 1 మీటర్ పర్ సెకండ్ అండి. ఓకే, ఆ v వచ్చేసి ఫైనల్ డెస్టినేషన్ ఉంది కదా, ఇదంతా 5 meters per second అండి. ఈ టైం ఏదైతే ఉంది కదా, ఇది 2 seconds. సో ఇది ఇంత సిచ్యువేషన్ ని అంత డెప్త్ లో పోయే బదులు ఒక లైన్ గీస్తే మొత్తం మీనింగ్ వచ్చేస్తుంది. బట్ ఆ మీనింగ్ ని మనం అర్థం చేసుకోవాలి. యూ నీడ్ టు అండర్స్టాండ్ ద డెప్త్ ఆఫ్ దిస్ సింపుల్ లైన్. This simple line which starts from here is proving that it already has certain velocity. If the same thing, if I write, okay, if I draw the line from here, it is understood that body ఇప్పుడిప్పుడే మొదలైంది, జీరో వెలాసిటీ నుంచి మొదలైంది, ఫైనల్ వెలాసిటీకి రీచ్ అయింది, టైం పట్టింది. ఈ లైన్ ని కొంచెం పైకి జరిపితే జీరో నుంచి స్టార్ట్ కావట్లే, ఆల్రెడీ కొంచెం స్పీడ్ ఉంది, ఎవడో ఒక కాల్తో ఆల్రెడీ తనినాడు, దాన్ని మూవ్ అవుతుంది, దాని స్పీడ్ పెంచడానికి మళ్ళీ ఒకసారి తనినాడు. అర్థమైందా? ఈ గ్రాఫ్ ఈ నుంచి మొదలైంది. సో యూ జస్ట్ ట్రై టు అండర్స్టాండ్. యాక్సలరేషన్ కావాలంటే స్లోప్ తీసుకుంటే నీకు యాక్సలరేషన్ కి ఫార్ములా వచ్చేసింది, విచ్ ఈస్ కాల్డ్ యాజ్ v minus u by t. బట్ అదే గ్రాఫ్ నుంచి దిస్ ఈస్ ద గ్రాఫ్ వేర్ యూ హ్యావ్ టు ఫైండ్ అవుట్ ద డిస్ప్లేస్మెంట్. దెన్ ఇఫ్ యూ ఫైండ్ అవుట్ ద ఏరియా విల్ గెట్ ద డిస్ప్లేస్మెంట్. ఎలా చూడు, నా దగ్గర ఒక ఈక్వేషన్ ఉంది. s ఈస్ నథింగ్ బట్ ut plus half at square. This is an equation which I have derived in the previous case. ఒక బాడీ ఉంది, one body is there which is moving with a constant velocity, ఎంత? ఫర్ ఎగ్జాంపుల్ 5 meters per second speed తో ఆల్రెడీ కాన్స్టెంట్ వెలాసిటీ పోతుంది. It doesn't have any acceleration. If the body has a constant velocity లేదా uniform velocity, acceleration part ఎగిరిపోయింది. There is no acceleration. A is equal to 0. Understood? So formula will become u into t, that's it. అండ్ డిస్ప్లేస్మెంట్ కావాలంటే ఇట్ ఈస్ అ ప్రోడక్ట్ ఆఫ్ వెలాసిటీ ఇంటూ టైం కదా. డిస్ప్లేస్మెంట్ కావాలంటే వెలాసిటీ ఇంటూ టైం. ఇక్కడ కూడా ఇది వెలాసిటీ, ఇది టైం. గ్రాఫ్ ఇట్లా లేదు, ఇప్పుడు ఇట్లా ఉంది అంటే ఏమి? యూనిఫామ్ వెలాసిటీ అని. ఇట్లా ఉంటే ఏమి? స్లోగా వెలాసిటీ పెరిగినట్లు. ఇఫ్ ఇట్ ఇస్ లైక్ దిస్, వెలాసిటీ ఇస్ కాన్స్టెంట్. ఫ్రమ్ దిస్ the product of velocity into time gives you displacement, the product of length into breadth also gives you area. So displacement is linked with area. So if you want to find out the displacement from this graph, you need to find out what is the area of this graph. Okay, you need to find out what is the area of that graph. So how are you going to find out the area of that graph? You just see here. No? So displacement is nothing but what is that? Area of a triangle plus area of a rectangle. This is going to be the triangle and this is going to be the rectangle. Okay, what is the meaning of area? Which area you have to consider? If you want to find out the displacement, you have to find out the area below the line. Which line? Green color line is representing the graph here. Situation is represented with green color line. A green color kinda enta area vastundo mottam area nuki padayala. And there are two areas here. Okay, what is this? This is area 1, this is area 2. Ee rendu areas kanukunte again you will get the same equation that we have to prove here. So how are you going to get the same equation once again now? So displacement is nothing but, first of all, let us take rectangle, then you take triangle. So rectangle first, okay, first take the rectangle plus again you take the area of a triangle. So rectangle is nothing but length into breadth. Okay, so initial velocity breadth ante t length ante t, breadth ante u kada, breadth into length anna, length into breadth anna okate. So it is nothing but u into t. Rectangle వచ్చేసింది. ఓకే, ఇది t అయితే ఇది u అన్నమాట, ఇది u అయితే ఇది t. సో దీంట్లో u into t, length into breadth వచ్చేసింది ఇక్కడ. నెక్స్ట్ వాట్ యు హావ్ టు ఫైండ్ అవుట్, ఏరియా ఆఫ్ ఎ ట్రయాంగిల్ కావాలి. సో ఏరియా ఆఫ్ ఎ ట్రయాంగిల్ అంటే ఏంటి, హాఫ్ ఇంటూ బేస్, బేస్ అంటే t. ఓకే, ఇంటూ హైట్, హైట్ అంటే ఏంటి ఇక్కడ v మైనస్ u కదా. ఎందుకు ఫైనల్ వాస్తు ఇది, ఇనిషియల్ వాస్తు ఇది, ఈ గ్యాప్ ఏమవుతుంది, ఇట్స్ గోయింగ్ టు బి ద డిఫరెన్స్, దట్స్ ఇట్, ఇజంట్ ఇట్? దిస్ ఈస్ గోయింగ్ టు బి ద డిఫరెన్స్ v మైనస్ u అంతే. సో దిస్ గ్యాప్ which is v minus u I have written here. Understood? I have written there. Okay, so what are you going to do from this now? Okay, now I got an area of a triangle. Area of a triangle is the formula. Then, but you already know A is equal to v minus u by t. So v minus u, can you write it as at? Okay, I am just replacing v minus u here. Okay, so that second area which is taken as a2, a1 kada, first area kada. So triangle is manaku kavalsindi, half into time, v minus u is written as a into t. So finally a1 is nothing but half at square, and a2 is nothing but length into breadth, which is nothing but u into t. So here the displacement is taken as the first area which is a2 కింద ఉంది, తర్వాత సెకండ్ ఏరియా which is taken as a1. So a2 which is taken as ut plus a1 which is taken as half at square is ready. So situational derivation is there and graphical derivation is also there for that. Hope you understand. Okay, so then you got half at square. So I have derived an equation. By using graph also. And in the previous case, I have derived an equation by using a simple situation and doing some mathematical calculations and doing some algebra. Okay, that's it. Okay, hope you're understanding. You got a second equation of motion also. So can we find out the third equation of motion, which is v square, which is called as the total basics of your whole physics depends upon these three equations. V square minus u square is equal to 2as. You have to derive the third equation of motion. Let us take one situation first of all. Situational derivation and graphical derivations are completely different. So what is a situational derivation? Let us see here now. A body has certain initial velocity, it is having certain final velocity, and it is moving with certain acceleration, it is having a displacement. Yes. Okay. Situation. Let us take your car is having initial velocity u, it is having an acceleration, slowly its speed increasing, having a final velocity v, it has traveled a displacement. Yes. Now, okay, so what is that we have got from this? You got that displacement is nothing but average velocity into time, which is v plus u by what is that, v plus u by 2 into t. So from this you will get one equation, v plus u is equal to 2 into s by t. This is equation number 1. I have explained up to here only. This is a new point I got from the previous old equation. This is a new point, a new equation I got. What is that? V plus u is equal to 2 into s. Hope you are understanding this point now.